We're going to talk a little bit about surface area. We've already talked about how to find rectangular prism surface area. And let's just review. Here's our rectangular prism here. And just like we were talking about when we had our tissue box, they have 6 faces. Okay, these 2 are identical. You can only see this one, but we know we have a back side that's identical. The top and the bottom would be identical, and then the 2 sides would be identical. Now you're not going to see all that on a flat picture, but you have to think about perspective, 3-dimensional, what it would look like. So we're just going to find area for each face. So we have the area of this front, which is 10, and the height is 6. So 10 times 6 gives us 60, and remember our units are always squared because we're talking about area. Then we have the face over here, 5 times 6, which is 30. We have 2 of those. There's one on the other side that we can't see. And then we have the top, which is 10 by 5. Is 50, and then the bottom would be the same way. So when we add up all those together, we have 50 and 50, 60 and 60, and 30 and 30. We get 200 centimeters squared. Okay? Now we got to remember that all we're doing to find surface area is adding up all the faces, all the areas of the sides, and then remember we have to have our units squared because we're talking about area. Now if you like formulas, this formula is pretty neat. Basically you have your length, width, and your height, and you can name any of these whatever you want. So if we want to name this one length and width and height, that's fine. They just stay that way forever. Alright, so we're going to do that. We're going to go ahead and name this one length. We're going to name this one width, and we're going to name this one height. Okay? It doesn't really matter. It's all about perspective. If we turned it upside down, we may look at this as the height, and this is the base, or as the length. So we can look at it differently. Okay? So our formula would be as this: length times width plus length times height plus width times height. And then once we do that, we multiply all that times 2 because remember we have 2 corresponding sides. So when I plug those in, again I get 280 centimeters squared. So either way works. Whatever way you like the best is fine, but I want you to start understanding where the formula comes from. Now we're going to start learning about surface area of triangular prisms. Now anytime that we say something with triangles, that is our base. Even if it's laying this way, you can think about turning up on its side, but the triangle is the base. So sometimes they'll say triangular-based prisms or triangular-based pyramids. You know that that's the base. Whatever it's saying is the base. Okay? So this one where we have a triangle, and then we have a long rectangle, and we got to think about our perspective here. Now notice here, this is our height of our triangle. This slant, the 13 feet, the slant is going to be on either side. And because this base here of the triangle is 10, the slant is 13, that'll bring red flags to me that this bottom piece, this bottom rectangle, is going to be different from this front rectangle that I see here and the one that's going to be on the other side. So I know that my formula for a triangle is base times height divided by 2. I'm going to plug in what I know. I know my base is 10, my height is 12, I divide it by 2, I'm going to get 60. That's just for this one piece right here. I know there's another piece on the other end, identical. I can't see it, but I know it's there. Okay? And then I have this front face here. Now this is a parallelogram or a rectangle. We can kind of see that if we cover that, it looks like a parallelogram, but the same formula applies, length times width or base times height. So we're going to do 30 times 13, we get 390 feet. Now there's another identical one on the other side of that because I can tell those are the same slants. Okay? And then I look at my bottom. My bottom's going to be a little bit different. My bottom is 30 by 10. Okay, it's not identical to this front one here. It's different because this base of this triangle is different. So 30 times 10 is 300. I do the same thing. I add those together. I have 60 and 60. That's for my 2 triangles, triangle here and the one that I can't see. And then 390 and 390, that's for this face here and the one on the other side that I can't see. And then my bottom is 300. And when I get that, I have 1,200 feet squared. Remember, our units are still square because we're talking about area. Now there is a formula. I particularly don't use this formula. I do it pretty much this way. It makes more sense to me, but there is a formula for those of you that like it, so we're going to talk about that for a second. Now our formula for a triangular prism is 2 times the big B. Remember, big B is area of the base, and when we're talking about a triangular prism, the base is the triangle. Okay, so we have to think about already doing that area for the triangle. Plus big P. P means perimeter of the base, and perimeter of our base would be the triangle. So it would be the perimeter of our triangle. So if we look here, that would be 10 plus 13, and we're going to assume the other one's 13, 13 as well. Okay, so that's the perimeter of our base. And then our height is the height of the triangular prism. Now, don't confuse the height here for the height of the triangle. It's not the height of the triangle, it's the height of the whole prism. And if we think about turning this up, that would be 30. Our height would be 30. Okay? So when we plug those into our formula, 2 times 60, and I've got my 60 from where I already did the area of my triangle. 2 times 60 gives me 120. I add 13 plus 13 plus 10, that's the perimeter of that base, and then I get 36, and then I times that by the height, which is 30, and I get 1,080. When I add those together, I get 1,200 feet squared. It's the same as I got before. So it's your preference on what you would like to use. To me, I like this a little bit better. I can see it. I know that I'm not missing anything, so I can make sure I don't make mistakes. All right, now we're going to get to square base pyramids. And we just talked about triangular base prisms where the bases are triangles. Now this is a pyramid, so we think about these in Egypt. Notice that the base of this is a square. And what we know about a square is all sides are the same. So this is 12. Obviously, because it's a square and it's telling us that, we know that this is going to be 12, this side's going to be 12, and this side's going to be 12. So we can look at this as a net, and if we draw this out as a net, we have a square in the middle, and then 4 identical triangles. And they're identical because they're coming off of a square. So we know their bases are all identical, and that gave us the slant height. Now, we're used to knowing this is just the height, and we look at it as triangle. It's just the height, but when they have it written as a slant height. And this is going to matter later because I use something a little bit different in the formula method for this, okay? And they'll give you this at your grade level. They'll give you what the height is there. You won't have to use Pythagorean theorem to figure it out or anything. It's going to be there for you. So we're going to look at just the base. We know that's length times width, or we can do side squared, 12 squared. So 12 times 12 is 144. So I know 144 centimeters is the area of the base of this pyramid. Okay? Then I have to look at all the triangles. Well, the base is 12, and the height, or the slant height they give us, is 8. So 12 times 8, and then divide by 2, we get 48. Now that's just for one of them. Remember, we have 4. So we have to think about 4 when we add those together down here at the bottom. So our surface area is 336 centimeters squared. Now it's really important that you understand how you can lay this out as a net, and that you can identify, if I gave you just the net, what it would look like. So that's something we're going to be getting into soon as well. Now, if we look at a formula, again, sometimes the formula gets a little bit complex, but I want to show you guys what it looks like. So we have a big B. Remember, big B means the base is already done for us. So that's the area of the base, and this is because it's a square. It's the area of the square, plus half P, big P, and that means perimeter of the base. And this little crazy looking L is not length, it is actually the slant height. They use that for the slant height, okay? So that would be our 8 in this situation. So we put in our area for our base, which was 144, plus half times the perimeter. Now it's the perimeter of the base, so we know that our base is a square, so it's 12 plus 12 plus 12 plus 12. We would have that here, that would be 48, times our slant height, which is 8. So when we plug that into our formula, we get 144 plus 192 equals 336 centimeters squared. So we see that we have the exact same surface area. Now, I'm a more visual, so I like this a little bit better. It keeps me from making mistakes, but you can use either way that you would like. Alright, the last thing we're going to talk about in this video is rectangular base pyramids. Now, you won't see these a whole lot in 6th grade. You actually will see them more in 7th grade when you have to use Pythagorean theorem, and in 8th grade to find those slant heights. That's a little bit complex. So right now, I just gave you the slant heights, or the height of the triangle, so you kind of already have that. And I made them the same. Technically, they probably would not be, but we just made them the same just so you could understand the same premise premise works for finding surface area once you know those slant heights. So we kind of took this apart. We have a a rectangle base on this one. So I just kind of drew it out, and our base is 10 by 7. So we just kind of labeled it here. I have two triangles that are identical. I have this big side triangle, and the other side is going to be identical to it, and it is 10 by height of 6, and I have two of those. And then the other one is going to have a different base. It's going to have a base of 7 and a height of 6. So those are different. A lot of people make mistakes and they just think it's the same way as a square base pyramid, and they find one triangle, multiply them by 4, and they go with it, and that's not correct. So you need to be very careful that you know that these two triangles here are actually different. Okay, they're different sizes. So when we work out our formulas and we put them in, this is 7 times 10 is 70. 10 times 6 divided by 2 gives me 30, but I have two of them. Okay, because one on each side. And then 7 times 6 is 42, divided by 2 gives me 21, and I have two of those as well. So I have 70 plus 60 plus 42 gives me 172 inches for the surface area of this rectangular base pyramid. Now, again, you won't see many of these without me giving you the slant height. We're not going to worry too much about formula since we don't see much of these right now, but I want you to understand the premise still works. Now, when we do a couple challenge ones with pentagon bases or hexagon bases or trapezoid bases, the same premise works. You just look at each piece and then see what comes off of that and connect those all together.